Okay, so the first thing that they do is they start by kind of reminding you what the graphs to square it function looks like. Okay, so you guys remember that the square root function is the top half of a parabola on its side, and you basically can move it up, down, left, right, and change the slope and so forth. So I probably don't need to do an example of that, right? And to be kind of honest, I don't know how relevant that really is to this whole situation, so I'm just gonna slide past that part. Okay, so I'm gonna go straight into solving square roots. Okay, so I'm gonna take this first example here, and we'll do this one. Example number 1. Okay, so solving square roots. Okay, so when I did this during second period today, they said, can we make a list of steps? Okay, so do you guys agree that making steps is beneficial, or? Okay. So I will also make a step list for you. Steps. Okay, so steps for solving radical equations, by the way, right? Okay. The first thing that you want to do to solve any radical is to isolate the radical. Okay, so in our case we have a square root. If I was going to isolate the square root piece, what would my first step be? Subtract the 2. Good. Okay, so I would have x plus 10 is equal to x minus 2. Okay, so first step is to isolate the radical. Okay, the second step is going to be to eliminate the radical. Okay, so if I have the square root of stuff, how do you get rid of the square root? You square. Okay, so in our case, we are going to undo it by squaring both sides. Now this is pretty tricky. On the right-hand side, I have a quantity. Okay, so when I square it, I have to square it as a quantity. Okay, so step 2, how should we say that? Eliminate the radical. Okay, so on the left-hand side, I have a squared square root. So what happens? They cancel out. So I'm left with x plus 10 on the left-hand side. What am I left with on the right-hand side? Okay, so x squared minus 4. Okay, so remember that if I have a quantity that is squared, remember that that's the same as x minus 2 times x minus 2, which would require me to FOIL. Okay, so we can go through and FOIL this out, or it might be beneficial for you to remember our difference of squares and sum of squares definitions. Do you remember those? I'll write them down for you so you can write them in this rainbow. Okay, so if we have a plus b squared, that is a squared plus 2ab plus b squared. Okay, the difference of squares basically only changes the minus of the very first ab. Okay, so that might be a good little trick to remember. So, can somebody tell me what the quantity of x minus 2 would FOIL out to? X squared, good. Minus Minus what? 4x, good. Plus 4, good. Okay, at this point, it just becomes solving, and it kind of depends on the scenario because things can be different depending on the equation. Okay, so in this case, we have a quadratic piece. Okay, how do I go about solving any quadratic? What must I do first? Set it equal to 0, good. So for this one, I'm going to subtract the x and subtract the 10. Okay, so I have 0 is equal to x squared. Let's see, that would be minus 5x minus 6. Okay, so maybe my third step in solving this would just be solve. I mean, it just depends. There's not any specific step that I can say, because sometimes you end up with linear pieces. Just depends. Okay, so now that I have it set equal to 0, I can try and factor this, or I could use, let's see, completing the square method, which I'm sure you all remember. No? What else we got? Quadratic formula.
I know that.
You know that one? So you want to do quadratic formula, or do you want to factor it using easy? Ooh. Do we need to put down a... Okay. Would you also like me to write down, remember what the quadratic formula is? Because you're probably going to have to use that at least once on the assignment. Or does everybody remember it? And can sing and dance to it? Anybody want me to write it down? Got it? Okay, perfect. Alright, so tell me what two numbers multiply to -6 and add to -5. Ooh, tricky one. It's going to be -6 and +1. This one is a tricky one with those 6's. Okay, so what are my two possible solutions? 6 and -1. Did anybody hear me say the word possible solutions?
How do you know?
Good question. How would I know which one's the correct one? Or maybe they both are correct ones. Or maybe they're both not correct. You plug it in, okay? So when you're working with radicals, it is very common to have extraneous solutions. What's an extraneous solution? It doesn't work. Like a number that we get by solving, but if you plug it back in, it doesn't work. Okay, so you have to check. So if we go back to the original and check 6, let's start with the 6. Okay, I'm going to plug it in the left-hand side. Notice we're going to have it be set equal to 6 eventually if this is true. What's 6 plus 10? Square root of 16? 4 plus 2 is 6. Is that a true statement?
Yes.
True. Check on 6. Let's try -1. What's -1 plus 10? Square root of 9. 3 plus 2 is 5 equal to -1. Not today. Okay, so -1 did not work. That is an extraneous solution. If you plug -1 in, yeah. It actually becomes pretty apparent as soon as you plug in -1, I would hope. Okay, if I plug a -1 in right here, do you immediately notice the right-hand side almost becomes irrelevant? Because if you have a negative number, is it possible for us to add a positive number plus a positive number to equal a negative number? See what I'm saying by that? Square roots always have to be positive, and if I add 2 to another positive number, I will never get to a negative number. Awesome? Shall we do another? You got it already?
Oh, yeah.
Actually, that's like the hardest one that I'm going to do. Yeah. Except for, I mean, this one is not really different. What's the only difference between this one versus the one I just did? It's an exponential form, okay? But my steps are exactly the same. I'm going to isolate the exponential piece, get rid of the exponential piece, and then just solve it. Okay, so how do I do this one? What's my first step? Okay, yeah, so I start by adding 2. Okay, and 1 plus 2 makes 3. Okay, so now I need to get rid of our exponential piece. So how would you get rid of something to the 1/2 power? To the squared power, yeah. Right idea, just said wrong. Okay, so left-hand side, the 1/2 cancels the squared. So what's left on the left-hand side? X plus 5. And everybody knows that 3 squared is 9. Okay, now this one turned out really nice. We're left with a 1-step linear equation to solve at the end. What's my 1 step?
Oh, sorry. -5. And then x equals 4.
So x equals 4. Now, can I just say good? I definitely know that's correct.
No.
No. Okay, we definitely want to check any of these radical equations. Okay, so if I plug 4 back in, what's 4 plus 5? 9 to the 1/2 power. 3 minus 2. 1 equal 1.
That's a 1 period.
A 1 period? Oh. I don't know, that's technically written within a sentence. Anyways. So the other piece they include in this is cube roots. So let's do a cube root, and that shouldn't be too bad. Okay. So a cube root is no different than a square root. Okay, we have again the same steps. We're isolating the exponential or the radical piece, getting rid of that exponential or radical piece, and just solving. So what would my first step be in question number 8? Divide by 2, good. Bless you. So we have x minus 50 to the 1/3 power, and negative 10 divided by 2 is, good, negative 5. Okay, and then how do I get rid of a 1/3 power? Cubit, good word, cubit. So my left-hand side goes away, or at least the exponent piece does, and I'm left with x minus 50. And negative 5 to the 3rd power is negative 125.
I don't know what that is.
You're kidding me.
75.
I feel like negative 5 cubed was harder.
Addition subtraction is not my strong suits.
Alright, so again we want to check the cubic. And this is kind of an interesting case, so pay attention to this for me. Okay? The first thing I would do is plug negative 75 in. Okay, now if I have a negative 75 in minus 50, what's negative 75 minus 50? Negative 125. And the cube root of negative 125 is negative 5. And negative 5 times 2 is negative 10. Now here's the thing to think about, because I can almost guarantee at some point in time they're going to try to trick you with this. Imagine that this would have said to the 1/2 power. Can anybody solve this really fast? Pretend for a second it said this. Anybody solve that? Should be done by now.
Oh, yeah.
Huh? It's an error? Roughly. What does an error mean?
But it's not mathematically correct.
Not necessarily correct, but possible.
Yeah.
Okay, this particular problem would have no solution. Anybody tell me why? It's actually not a parabola. It's a square root. It does pass the vertical line test.
Can't get a negative.
You're getting closer. Okay. If you're thinking graphically, then correct. It does not pass the x-axis. So we could look at this and I'll show you what it looks like. So remember that you can solve any equation by graphing if we just set it equal to 0, right? So technically you can make sure you got all the right answers on these questions. Just set them equal to 0 and graph. So if I did that for this one, what do we have? What did I have in front? A 2? 2 square roots of, what was it, x minus 50? And then plus 10, if I set it equal to 10. Yeah, so if I set that equal to 10, I would just, whoa, look at that. There it is. So where does it cross the x-axis? Nowhere. So tell me why this is no solution.
Doesn't cross anything.
True, but why does it not cross the x-axis? There must be a rational explanation.
Math gods.
You can't get a negative answer. Square root.
Right. Say that louder. Bree's got it.
You can't get a negative answer from a square root.
You can't get a negative answer from a square root. Okay, this is technically saying the square root of this stuff. Is it possible for a square root to equal a negative number? No, not possible. So that's why it's a no solution. Okay, so you could have solved that algebraically and eventually plugged it back in and found that the one solution that you did find was an extraneous solution, so therefore it was a no solution. But just be aware of that case. Okay. Okay, that's all I got. Good work. It's a short one today.